So one of the things I'll be testing over this learn at home time is doing videos and posting them to YouTube. So I decided a good place to start would be some of the homework problems we've been working on over the last week or so involving nonlinear systems. I'm going to skip the first four problems, which were more Algebra 1 problems, where you had to use elimination and substitution. And I wanted to jump into numbers 5, 6, 7, and 8. And I'll show you at the end of the video where I will post the answers, but I at least wanted to walk you through some of the processes you would use to solve these. And so on number 5, you are solving this system by elimination. And so how do we eliminate variables? Well, kind of the same way we did before. And I believe we walked through this one in class, but we'll kind of step through it again. First thing I would suggest doing is rewriting the first equation. And then the second equation I'm also going to rewrite, but you'll notice that it does not have an x squared in it. So I'm going to go ahead and rewrite it, but I'm going to line up the x's and the y's and the numbers so that they'll make them easier to deal with. And so if I were to add these two equations together, the whole idea behind elimination is you'd like one of the variables to cancel. So in this case, notice the y's, if I do negative y plus y, let me do that in a different color. Negative y plus y, they cancel because that is equal to 0. And then I do x squared plus nothing here, so there's nothing to combine with it, but we're going to go ahead and write that as x squared. And then you have x plus x, which is equal to 2x. The y's are gone, and we have equals negative 1 plus 4, which is 3. And so by eliminating the y's, we now have ourselves a quadratic equation that we have to solve. And like any quadratic equation that we've done over the last couple of weeks, you cannot solve unless it is set equal to 0. So since this is a positive 3, I'm going to go ahead and subtract 3 from both sides. And that gives me this particular equation. Now you have two options for solving this. Either one works. I would recommend going with whichever one you're comfortable with. I would hope that by this point you could do both of them. And so the first method behind solving these is the AC method. And so essentially that's factoring. I apologize for the slow writing. It's a little difficult to write with a mouse. And so the AC method says to take your particular function, identify the A, the B, and the C. So if we do that, our A is equal to 1, our B is equal to 2, and C is equal to negative 3. And so if I do A times C, AC is equal to negative 3. And so I'm looking for numbers that multiply together to equal negative 3 that will somehow give me positive 2. Luckily for us, 3 is a prime number. So the only numbers we can use are 1 and 3. But I need this to be a negative 3, so one of these two numbers has to be a negative. And so since I want this to be a positive 2, I'm going to make the 3 positive and the 1 negative. And so using the AC method says to split this middle term. So we leave our x squared out front. We leave our negative 3 out back. We still set it equal to 0. And now the 2x splits into a negative 1x and a positive 3x. And so that's the first step of the AC method. Second step is you look at each of the 4 terms and you pair them together. And so looking at these two guys, we want to identify any common factors that you can divide out. So in this case, there is an x that you can divide out of both of them. And so if we divide an x out of an x squared, you're left with x. If we divide an x out of a negative 1x, you're just left with a negative 1. And now if this is done correctly, we're going to do this again, but the parentheses on this side need to be exactly the same as the first parenthesis. So we need another x minus 1. And so looking at these numbers, the only number that we can pull out of that is a positive 3. And by the way, at any point in time, if I go too fast, just pause the video, write it down, replay it, and see if you can follow along. And so now I have an x minus 1 and an x minus 1 in each of these chunks, if you will. So I'm going to go ahead and pull that x minus 1 out from each of these groupings. So I pull x minus 1 out of this, and I pull x minus 1 out of this. And so the only thing that's left out of the first part here, if you pull the x minus 1 out, is that x. And the only thing left here is plus 3, and you have factored. Once we do that, we do the zero product property, which basically says take each one of those parentheses and set them equal to 0. And so this first one, if I add 1 to both sides, I get x is equal to 1. Here, I'll subtract 3. And so my two answers are 1 and -3. Now, we do have one extra step because this is a system of equations, and we're basically finding the coordinates where each of these two graphs intersect each other. So you have an x coordinate, but you also need a y coordinate. So I'm going to use this equation. You can actually use either one. And that equation is x plus y is equal to 4. And I need to plug in each of these x values to find the y value that goes with it. And so the first one, if I plug x equals 1 into this, I get 1 plus y is equal to 4. And if I subtract 1 from both sides, I get positive 3. Same thing for x equals -3. I plug in x equals -3, and I get -3 plus y equals 4. To get rid of a -3, you add 3 to both sides. And so that gives me y is equal to 7. And so my answer to this first solution right here gives me a coordinate of 1, 3. And the second gives me a coordinate of -3, 7. The other alternative to this, if we make a copy of this, is instead of using the AC method, is you are allowed to use the quadratic formula. I know some of you are a little more comfortable with the quadratic formula. And so the idea behind that is you still keep, so we'll write quadratic formula. And I'm going to shorten it up because it is a little difficult to write. And so we've got x squared plus 2x. Keep in mind you still needed to set it equal to 0, so do not use this form of the equation. So -3 equals 0. And we identified already that our a was equal to 1, our b was equal to 2, and our c was equal to -3. And so now if I use the quadratic formula, x is equal to negative b, or opposite of b, plus or minus the square root of, and hopefully you guys can still sing this, b squared minus 4 times a, which is 1, times c, which is -3, all over 2a. There you go. And so we do a little bit of simplifying in here. This intersection, this part of this is probably the most commonly missed, so be careful, watch your signs. For example, I see a -4 and a -3. So when you multiply a negative times a negative, you're going to get a positive. And so plus or minus. So -4 times 1 is -4. -4 times -3 is positive 12. So inside, I get 4 plus 12 is equal to 2. If I continue that, I get 4 plus 12 is 16. I get the square root of 16, which is 4. And now the plus or minus tells you that there are actually two answers. And so my first answer for x is -2 plus 4 divided by 2. And my second answer is -2 minus 4 equals 2. And if I solve these, -2 plus 4 is 2. 2 divided by 2 is 1. And then here, -2 minus 4 is -6. -6 divided by 2 is -3. And so there are our two answers, 1 and -3, which if we go back to the previous slide, we had 1 and -3. So the exact same answers. So when you're solving these, if you are comfortable using the AC method, it does get a little harder at times, use it. Or some of you are very comfortable with the quadratic formula. The key is make sure you set it equal to 0 before you do either one of these methods. So I will not work through all of numbers 6, 7, and 8, but I'll at least push you in the right direction. So on number 6 here, the first step is to eliminate y. These are already perfectly lined up for us. And so the y's cancel. And if I add my x's, I get 2x squared. And then I add these guys together. I get -3x. I add the y's, they cancel. And then I add these numbers together and I get 2. So I get 2x squared minus 3x equals 2. And again, I do not want it set equal to 2. I want it set equal to 0. And so we get 2x squared minus 3x. I need to subtract 2 from both sides. And I get this. So again, once you reach this point, your two options, which I will not work out on here, but I will provide you the answer key. You can use the AC method, or you can use the quadratic formula. Okay, for number 7, I ask you to use substitution. Now, substitution is slightly different, but it works kind of the same way. With substitution, your whole goal is you're trying to eliminate one of the variables. And this first equation, y is equal to negative x squared plus 4. And the idea behind substitution is y and negative x plus 4 are equal to each other, which means they should be interchangeable. You should be able to replace one with the other. So if I come down to this second equation, I see a y that's floating around over here on the left. What I'm going to do is I'm going to pull that y out and replace it with negative x squared plus 4. And then the rest of the equation stays the same, equals negative 4x plus 8. And then the y's are gone, similar to what we did for these earlier problems. You want it set equal to 0. I think one of the things you want to try to avoid, it's not absolutely necessary, but it helps, is you really, really don't want the x squared term to be negative. So normally, we would take these two terms, the negative 4x and the 8, and bring them over to this side by adding 4x and subtracting 8. I'm not going to do that. I'm actually going to move these two terms over to this side. So to do that, I need to add x squared to both sides, and I need to subtract 4. And so if I do that, nothing is left over on the left side. The x squares will knock each other out. The 4 and the negative 4 knock each other out, so you're left with 0. Over here, I added x squared, but there were no other x squareds over here. So the x squared is just going to be by itself. The negative 4x is also by itself. But then the 8, I ended up subtracting 4. So I get x squared minus 4x minus 4. And if you like, just go ahead and swap sides here. You're allowed to do that with an equation. I'm just going to move the 0 to the right side. And then I get x squared minus 4x minus 4 on the left. And then we're right back to where we were. Your two methods are the AC method, which I think will work very well here because you have a 1 out in front of your x squared, or the quadratic formula would also work nicely. Lastly, number 8, also using substitution. And so looking at these two equations, this is clearly the more complicated of the two. So I'm going to focus my early attention on this guy. And what you want to do is you want to isolate a variable. Like pick the variable that doesn't have a number out in front of it, which in this case is y. And my goal is I want to get y by itself. And so if I do that, I need to get rid of the 2x. And since this 2x is positive, I'm going to subtract 2x from both sides, which means y is equal to 5 minus 2x. You could also write that as y equals negative 2x plus 5. Either way is correct. I think for some of you, this one will make a little more sense. So for right now, we're going to ignore that. Once I did that to the second equation, I'm now going to substitute into the first equation. So the first equation is x squared plus 3x plus y. But instead of y, I'm going to go ahead and replace it with 5 minus 2x equals 0. Now I put parentheses around this, which I didn't really need to do, but it's a good habit whenever you substitute values such as this in. You usually want to use parentheses because a lot of times there will be a number out in front, like a 2 or a 5, where you'll end up having to distribute. So in this particular problem, there's nothing outside. So really, I can just get rid of the parentheses, but it's just a good habit to get into. And now this one's already set up nicely for us because it's set equal to 0. So the only thing I have left to do is I need to combine any like terms together and make sure that my terms are in descending order. So my x squared first, the x terms next, but now I've got a 3x minus 2x, which gives me a plus 1x, and then plus 5 is equal to 0. And so now you've got a situation here where you can solve, and I will give you a little tip here. If you try to factor using the AC method, it will not work. There are quite a few polynomials or quadratics that you'd like them to factor, but they do not. So the only option you have here is to use the quadratic formula. And your answer will not be nice, neat, x equals 1, x equals -3. You'll get some weird problems, and you may end up with something strange inside your square root when you do the quadratic formula. So I will leave that here. On the website, if you want to access the answers, it's a little difficult to see here, but this is a screenshot of my website. So just go to the website up top, click on Algebra 2. One of the sub-menus on Algebra 2 is Chapter 3. So if you click on the Chapter 3, it will take you to this page. Scroll down to the very bottom, and I have a file called 3.5 Nonlinear Systems. So the first link here is a blank copy of the worksheet. So if you lost it and you need to print it out, you can do that. And then the second one is a link to the answers. And you can see all the problems, not just the 4 I did, but also numbers 1 through 4. If you're on the mobile version, just scroll all the way down. It'll be at the very bottom. So I will post this video, and if you have any questions, please feel free to email me.